Hello my dear students, welcome to my YouTube channel that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today's topic for the lecture is the electron gain enthalpy, or we can say the electron affinity. What is electron gain enthalpy? The electron gain enthalpy is the energy evolved or liberated when one electron is added to the isolated gaseous atom. So electron gain enthalpy is the energy evolved, or it is the energy which is liberated when an electron is added to the isolated gaseous atom. This is an exothermic process, the process in which the energy is liberated to the surroundings. That stands for exothermic process. And electron gain enthalpy is an exothermic process when an electron is added to the isolated gaseous atom. The process is represented as a gaseous. When it gains a 1 mole of electron, it forms me 1 mole of A negative ions. So the enthalpy change for the above reaction is called the electron gain enthalpy, which is represented by delta Eg. What next I have written, the electron gain enthalpy is an exothermic process and hence will have the negative values, but I'm saying that when we will consider the orders in the periodic table, we will ignore the negative sign. We will concentrate on the numeric value. Negative sign just signifies that the electron gain enthalpy is exothermic process, that is energy is liberated to the surroundings. Now the magnitude of electron gain enthalpy will depend upon the following factors. The very first factor is the size of an atom. Smaller the size of an atom, added electron will be more closer to the nucleus and hence greater will be the electron gain enthalpy. Now, the second is the effective nuclear charge. Greater the effective nuclear charge, the stronger is the attraction for the added electron towards the nucleus. Thus, the electron gain enthalpy increase with the increase in the effective nuclear charge. Now, third one is the electronic configuration. The elements having stable half-filled or fully filled electronic configuration have very little or no tendency to accept the additional electron. Hence, the electron gain enthalpy are low or zero in these cases. For example, some noble gases. Now, let's talk about electron gain enthalpy down the group. We are going to discuss the trend of the electron gain enthalpy down the group. Now, let me take an example. I am taking the example of group number 1. The group number 1 is hydrogen, lithium, sodium, potassium, rubidium, cesium, and differentium. In the group number 1, as we move down the group, I'm writing as we move down the group, the number of shells increase. The number of shells increase for every successive element. Hence, what will happen? The size will increase. The size will increase. The screening effect will increase. The effective nuclear charge will decrease. The effective nuclear charge will decrease. Due to all these factors, it will be tougher to add an electron to the atom, and hence the electron gain enthalpy will decrease down the group. The electron gain enthalpy will decrease down the group. In case of electron gain enthalpy, I have already mentioned you that electron gain enthalpy will have the negative values. While considering any trend or considering any order, you have to ignore that negative sign and you have to just concentrate on the numeric value. The negative sign signifies that it's just an exothermic process. Please don't get confused. We have to consider the numeric values, we don't have to consider the negative sign. So as we move down the group, the number of shells increase for every successive element, the size will increase, the screening effect will increase, the effective nuclear charge will decrease. All these factors will contribute to the decrease in electron gain enthalpy down the group. Now let's come to the period. Electron gain enthalpy across a period. Let me take an example of a period. I'm taking lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and the neon. Now, what will happen when we move across a period that is from left to right? We are moving from left to right. What will happen? The very first point is the shell number will remain same. The shell number will remain same. The second point will be the effective nuclear charge will increase. The effective nuclear charge will increase. The third one is the screening effect will decrease. The screening effect will decrease. Now, all this factor, the fourth point is the atomic size will decrease, the most important. The fourth one is atomic size will decrease. All this factor will contribute for the ease of an electron to get added to an element. So due to all this factor, what will happen? All the above factors, will increase the tendency of an element, will increase the tendency of an element to gain electron. Thereby what will happen? Thereby electron gain enthalpy will increase across a period. So these were the general trends of electron gain enthalpy across a period and down the group. The electron gain enthalpy will decrease down the group, and on the another hand, electron gain enthalpy will increase across a period. We have to ignore the negative signs. The negative sign just signify that electron gain enthalpy is an exothermic process. Let's come to a periodic table. Now, here you can easily observe that. Let's talk about the group number 1. You have to just ignore the negative values, the negative sign, sorry. We have to just ignore the negative sign. Now see the numeric values. For hydrogen 72.8, then 59.6, then 52.9, then 48.4, then 46.9, then 45.5. Here you can see that down the group, electron gain enthalpy, the electron gain enthalpy is signified by delta Eg. The electron gain enthalpy decrease down the group. It indicates that down the group the tendency to gain electron by an element decrease, thereby less energy is evolved down the group when an electron is added to an element, so the electron gain enthalpy decrease down the group. You have to concentrate on the numeric values, you have to just ignore the negative sign. Now let's talk about the period. Now across a period, I'm taking the period number 2. That's the period number 2. It's 59, then 0, then it's 27, 121, then 141, then 328. The electron gain enthalpy increase across the period. That is, tendency to gain electron by an element increase as we move from left to right, because effective nuclear charge increase and the atomic size decrease. So the electron gain enthalpy will increase across a period with some general exceptions like that of nitrogen, because have a stable half filled electronic configuration. Is an example exception. The nitrogen is an exception because it has a stable half filled. It has a stable half filled electronic configuration. So these were the general trends of the electron gain enthalpy down the group and across the period. The electron gain enthalpy decrease down the group and electron gain enthalpy increase across the period. Now let's come to the another exception of the group number 16 and the group number 17. Here you have to observe that electron gain enthalpy as a general trend has to decrease down the group. The electron gain enthalpy has to decrease down the group, but in case from oxygen to sulfur, the electron gain enthalpy is increasing and then it is decreasing down the group. Oxygen to sulfur, electron gain enthalpy increase, then sulfur onwards, electron gain enthalpy decrease. On the other hand, for the group number 17, that's for fluorine, from fluorine to chlorine, electron gain enthalpy again increase, then chlorine onwards, the electron gain enthalpy decrease. Why? The question is why oxygen has lesser electron gain enthalpy than sulfur, and why fluorine has lesser electron gain enthalpy than chlorine. Now let's discuss about this in the notes. Now let's come to an exception. I'm taking it in an questionable way. The question is why oxygen has lesser electron gain enthalpy than sulfur, question mark. Now oxygen and then it's sulfur. I'm writing the size of oxygen is very small. The size of oxygen is very small, due to which what will happen? Due to which the incoming electron will get repelled by the electrons already present in oxygen. So due to this inter-electronic repulsive forces, oxygen will have a lesser electron gain enthalpy than sulfur. I'm writing due to this inter-electronic repulsions, oxygen will have lesser electron gain enthalpy than sulfur. And the very same reason goes for the fluorine and the chlorine also. I'm writing same reason is for the lesser electron gain enthalpy of fluorine than chlorine. The size of fluorine is also very small, so the incoming electron will feel more repulsive forces by the electrons which are already present in fluorine, due to which the fluorine will have the lesser electron gain enthalpy than chlorine. So that's all for the topic of the electron gain enthalpy. And at the last, again I'm again saying that for considering any trend across the period and down the group, you have to ignore the negative sign. Negative sign just indicates that electron gain enthalpy is an exothermic process. You have to consider the numeric values only. So that's all for today. I hope you all understood today's lecture. If any student wants to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.